Now that is breaking down. That is breaking down in many states, and it is breaking down, as I mentioned earlier, through restructuring, because new generation has been proved to be competitive. So the utility no longer has a monopoly control over its own generation. New generation is much cheaper than the old cost of generation, and so an electric customer who can possibly access power supplies for 3 to 4 cents a kilowatt hour certainly doesn't want to buy it from its local utility at 6 or 7 cents a kilowatt hour, but the traditional regulatory model would require that customer to take power from that utility. So we're seeing a real change in the regulation of utilities, and California again is probably taking the lead in trying to find a way to structure its regulation in order to meet those needs.
Thank you. Another issue that might be of interest has to do with the arguments related to the public interest versus private ownership in the case of power utilities. Is there a contradiction between the enhancement of public welfare versus profitability in the case of consumers and power companies?
I don't think there is. In the United States, there has been for many, many years a great tension between the utilities which are publicly owned and those that are privately owned. Publicly owned utilities, such as those that serve the city of Los Angeles and the city of Sacramento in California, are often at odds with large privately owned utilities like Southern California Edison, San Diego Gas and Electric, and Pacific Gas and Electric Company. But the reasons for the tensions between public and private ownership in the United States are, in my view, largely due for historic reasons in the United States, due to certain benefits that one side thinks that the other obtains, which results in the two being seen as not being able to compete fairly against each other. I don't think that necessarily has to be the case, and I think for other countries it probably shouldn't be the case, particularly where you're starting with typically a state-owned utility providing all of the service in the country, and if the country is thinking of inviting private investment for new power plants or possibly privatizing a portion of the existing system, that doesn't have to carry with it some of the problems that the United States has seen in the relations between public and private ownership. If you have the proper regulatory mechanisms to balance the need for private owners to earn their investors to earn a fair rate of return, while at the same time protecting customers against exploitative rates, good regulatory systems can do that, then I don't think there's a tension that can't be resolved between public and private ownership.
Very good. I understand that you served for 18 years as Chief Legal Counsel for the Electric Supply Business Unit of the nation's largest utility company, Pacific Gas and Electric. We are being viewed today by a number of distinguished power companies from Latin America. What were the issues you dealt with most commonly, and what is the importance of modernizing management practices in this industry?
The issues that I dealt with most commonly during that period related to the exchanges of utility services between Pacific Gas and Electric Company and other utilities in the western United States, which included up into the northwest and down into the inland southwest. The Electric Supply Business Unit at PG&E is responsible for the generation of electricity, transmitting it to load centers, and for electric resource planning. So my job was to advise that business unit how best to meet its business objectives. As the business became much more competitive, and one of my themes this morning has been that generation is a competitive business and the utility is being required to open up its transmission to use by competitors. Part of what I had to do was to advise my clients on the best way to respond to these changing regulatory requirements and economic forces. And that became the company was very responsive to this, but it was a major issue because of the change of the utility from being a regulated monopoly to a competitive business, and the change from the fact that years ago, not so many years ago, A utility could simply decide how much money it needed to run its business. Then it could go tell the Public Utilities Commission it needed that much money from rates in order to run its business, and the PUC would give them the money. Now it can't do that. Now it simply has to decide how much can I charge my customers for that product, and I will have to live within the amount of revenue generated by that. That's a fundamental change, and much of what I've done is help my client transition from the former model to the current regulatory model.
Along these same lines, in terms of your experience, was the transfer and exchange of technology, products, and services internationally a priority?
With the regulated utility at PG&E, it was not a priority. And the principal reason for that is that the source of revenue for the utility business at PG&E were ratepayers in California. So the regulators didn't want to see a lot of international activity by the regulated utility. However, PG&E and other utilities have created unregulated businesses, and they've set up accounting barriers so that there's no cross-subsidies from one side to another, so that the ratepayers in California or customers in California aren't kind of paying for some of the international activities of the utility. Right now, PG&E is very active internationally in international power development, and in that sense, clearly the company is having a great deal of international involvement. It's a very high priority, and it will be exporting products. It will be joining in joint ventures for new generation in other countries, including in Mexico.
And you would expect this to continue on in the future?
Absolutely, and I think there are a number of utilities that are doing that. In fact, the way now in which utilities are going to be able to provide greater shareholder value is through their unregulated business activities. But in order to be successful, they're going to have to stay close to their core competencies. These are energy companies. These aren't drugstores. These aren't sporting goods companies. They're not land developers. They're energy companies. So what they'll be doing is trying to leverage off their energy competency in development in other countries.
Very good. One final issue I'd like to ask you about, and that is, what is the scope of the professional services of the Energy Practice Group at McKenna and Cuneo? And are these types of specialized services available also in Latin America?
The scope of services that I and my colleagues at McKenna and Cuneo can provide runs a wide range, including transactional work that is helping put together energy projects, deals, arranging for power supply agreements, arranging for financing. One of the great assets we have is that certainly one of the partners in the San Diego office of McKenna and Cuneo, who does have a significant energy practice, is bilingual, and I think that gives us a great opportunity to help in Latin America. One of the areas in which really induced me to go into private practice and leave my Pacific Gas and Electric Company was that I saw the restructuring that was taking place internationally, and I felt that I had some knowledge and expertise that I could use in advising governments and advising companies and in creating the right institutional and regulatory mechanisms to deal with restructuring. So we can provide those kinds of services. Frankly, my view is that those services are probably not currently available in Latin American countries, simply because there hasn't been a need to develop that type of expertise, given that most of these countries have state-owned utilities that don't have the same kind of regulation that American utilities have had, and haven't faced yet the same kinds of competitive forces, but they seem to be moving in that direction now. So certainly over time they will develop those specialties, but I think right now they probably do not have them.
Thank you very much, Mr. Oglesby. You've provided us with some very interesting comments, and we will now continue with Module 2, in which Mr. Sandoval will discuss energy efficiency.
We have just heard a presentation on the vital role that energy plays from the global, societal, and environmental perspectives. Energy is certainly an important factor to be considered in the shaping of national energy policy. The importance of energy resources can also be understood through the application of macroeconomic theory in the planning and assessment of national economic growth strategies. I would now like to explore the importance of energy efficiency from the business perspective. In this discussion, I will focus on an in-depth description of how efficient energy utilization can boost manufacturing productivity, improve business economic viability, and improve industrial competitiveness. In particular, I will describe the types of programs that have been developed by electric utilities to promote energy efficiency among their industrial customers. Utilities can provide significant assistance to their customers in helping them manage their energy costs. San Diego Gas and Electric, for example, has helped save its customers over $400 million in energy costs since 1989. Before describing some of the programs that have been developed by gas and electric utilities in the United States to promote the efficient use of energy, I would first like to mention the current movement toward deregulation of the electric power industry in the United States. Although this is a complex process, it is clear that competition and customer service will be the cornerstones of the electric power industry in the near future and into the next century. In anticipation of these pending changes, electric utilities have identified strategic business objectives that are vital to their continued economic viability in this new era of competition. Utilities may seek to increase earnings. Utilities must continue to show strong financial performance in order to satisfy shareholders and to maintain the lowest possible cost of capital. Utilities must reduce energy costs. In order to provide a competitive price for electricity, utilities must reduce their production cost. This generally results in focusing on primary business objectives and essential customer services. Utilities seek to build alliances. In order to be a more effective player in the marketplace, utilities are forming new alliances with other businesses and community groups of similar interest. One example is the formation of joint business ventures between electric power companies and the telecommunication industry to provide enhanced customer service options. Provide quality service. Utilities realize that they must provide the highest level of service if they are to survive in a competitive marketplace. Utilities must take a leadership role in protecting the environment. Because environmental protection is of primary importance to their customers, it must also be an integral component of their business activities and planning. Utilities must proactively meet customer demands. If utilities are to continue to provide energy to their customers, they must understand their customers' needs and plan on how best to meet those needs at a competitive price. Many commercial and industrial customers have similar business objectives as their gas and electric utility company, as we can see here. Customers also wish to reduce costs, optimize productivity, increase profitability, and provide a quality product. Because the needs of both entities can overlap, many utilities are looking for ways to provide mutual benefits to their customers and themselves by providing services that meet the mutual business needs of both. We can begin to identify areas of common concern between business and utilities by analyzing how energy is used in industry and also by understanding utility energy pricing. Generally, the industrial production process requires an input of labor, raw materials, and energy. The cost of manufactured goods and services depends on the cost of these input requirements. Business productivity and profitability can therefore be increased by lowering these production costs per unit produced. Efficient energy use may be achieved through the implementation of various energy management strategies. These can include the installation of advanced manufacturing technologies, modification of production schedules to take advantage of lower energy prices, and the installation of energy-efficient equipment, such as motors, fluorescent lamps, and electronic ballasts. Full cost accounting, a method for accounting for all costs and benefits that are associated with a business activity, may be used to quantify the benefits and cost attributable to any potential energy investment. The benefits, for example, associated with the replacement of standard efficient fluorescent lamps with more efficient lamps would include lower energy costs, lower maintenance costs, and lower material costs due to longer lamp life. Costs would include the incremental cost increase of the more efficient lamp. Labor costs to replace the lamps could be eliminated by careful planning to replace older lamps with efficient lamps as the older ones burn out. The energy investment should be pursued if the net present value is positive. That is to say, if the present value of the sum of all benefits are greater than the present value of the sum of all costs over time. Other costs and benefits may involve lower secondary energy costs, lower overall maintenance costs, reduced waste, and higher plant utilization. The objective of demand-side management strategies is to optimize the efficient use of energy in the customer's production process. Utilities offer financial incentives to customers adopting these strategies. Incentives may be in the form of direct cash rebates, special tariffs, or equipment lease programs. Incentives are derived from the present value of the utility's deferred energy and capacity costs. Industrial energy prices often consist of an energy and demand component. The energy component represents the utility's fuel and operating costs of providing energy. The demand component represents the capital infrastructure needed to bring electric power to the customer's facility. Energy prices during the on-peak period can be up to 4 to 5 times more expensive than off-peak electric prices. This is due to the electric demand charge that is incurred during the on-peak period and to the higher cost of electricity during the time of day when it is in greatest demand. Here are a few demand-side management operating strategies that can benefit both customers and utilities. Peak clipping. Peak clipping seeks to avoid the on-peak demand charge by maintaining a facility's electric power demand at a preset level. This can be achieved by shutting off plant equipment so as not to exceed a preset demand level, or by synchronizing plant equipment so that the preset electric demand is not exceeded. It may also be achieved by the operation of an electric generator. Generated power would be used to meet electric demand that is in excess of the preset limit. Valley filling. The objective of this strategy is to increase consumption during the off-peak time of use period to take advantage of lower off-peak energy prices. Load shifting is similar to valley filling strategy in that on-peak load is shifted to the off-peak period. This may be achieved in practice by shifting production schedules from on-peak to off-peak periods and by generating and storing thermal energy during the off-peak period for later use during the on-peak period. Significant energy savings can result from the avoidance of peak electric demand charges. Several thermal energy storage technologies have been developed to take advantage of this strategy. Strategic conservation. Strategic conservation results in the overall reduction in energy consumption. This may be achieved through the installation of energy-efficient motors, lighting systems, air conditioning equipment, or refrigeration system components. It may also be achieved through plant maintenance and system re-engineering to improve equipment utilization. The most common cost-effective opportunities exist with equipment that runs for extended hours and for which a low-cost, energy-efficient solution is available. Many industrial companies have found significant energy savings opportunities, for example, by simply cleaning air filters and fixing leaks in compressed air systems. Compressed air is widely used in many industrial processes. It is used to drive pneumatic tools and to power automated manufacturing processes. A 1/8 hole, for example, can cost up to $3,000 per year in added energy costs. Also, many compressed air systems are overpressurized. A 2% drop in pressure can produce a 1% reduction in energy costs. Strategic load growth. The objective of strategic load growth may be viewed as the increased use of energy to improve product quality and to reduce overall production costs. Examples of this strategy exist in the use of advanced electro-technologies, which lower other production costs such as warehousing, shipping, fuel storage, waste, and emission costs. Dynamic load shaping refers to the flexibility to shift end-use load in response to shifts in demand on the utility electric power grid. Historically, utilities have shared a long relationship with their customers. By focusing on meeting the energy needs of their customers, they enable their customers to focus on operating their business. Because of the past long-term relationships between utilities and customers, utilities have a great opportunity to better serve their customers based on their expertise in power generation, transmission, distribution, and energy use efficiency. Generally speaking, because gas and electric utility companies are in the energy business and conduct energy audits of customer facilities, they may be able to identify common system-wide problems and to orchestrate the bringing of technical expertise to assist their customers in solving these problems. For example, utilities can hire experts to present seminars on solutions to common energy efficiency problems, or can use their telecommunication and video conference capabilities to facilitate the transmission and exchange of information to solve customer energy problems. Utility efficiency programs for industrial and commercial customers usually fall into two categories: demand-side management programs and customer service programs. Demand-side management programs focus on the promotion of energy efficiency, while customer service programs focus on additional utility services to meet specialized customer needs. Typical demand-side management programs focus on end-use categories within customer market groups. A typical portfolio of utility energy efficiency programs may include an energy efficiency improvement program, which is designed to offer direct cash rebates to customers for the installation of efficient equipment. This type of program is often implemented in coordination with area mechanical contractors and equipment vendors. A commercial and industrial lighting program, which is focused on the promotion of efficient lighting systems. The program is based on a fixed cost agreement between the utility and reputable lighting contractors to install efficient fluorescent lamps, ballasts, reflectors, controls, and sensors in the commercial and industrial customer facilities. A custom efficiency improvement program, which is designed to provide custom engineering and technical assistance to specific customers. A commercial and industrial motors program, which is also marketed in conjunction with motor distributors and maintenance contractors, a new construction program that is dedicated to the promotion of energy-efficient alternatives to architects and construction project developers, and a power quality program that focuses on helping customers in solving their power quality issues. I would now like to describe each program in more detail. The Energy Efficiency Improvement Program at San Diego Gas and Electric consists of an on-site energy audit of the customer's facility to identify energy-saving opportunities. The program is specialized for small and medium-sized commercial and industrial customers. Recommendations for energy savings are given to the customer together with estimates of costs, savings, and the amount of utility cash incentive. The Commercial and Industrial Lighting Program is designed to promote efficient energy lighting to large commercial, industrial, and municipal customers. The program consists of a detailed lighting audit and specific recommendations for efficient lighting systems. Recommendations typically include the replacement of incandescent lamps to either compact fluorescent lamps or tubular fluorescent luminaires. Electronic ballasts are also recommended together with occupancy sensors, photo sensors, reflectors, programmable controls, or even skylights whenever applicable. Industrial types of efficient lighting systems are also recommended. The audit recommendation consists of a list of materials, estimate of cost and savings, incentive amount, and list of available lighting installation contractors. Because lighting systems could operate for many hours per year and the replacement costs can be relatively low, they are generally a good business investment. The Custom Efficiency Improvement Program is designed for customers with an electric demand greater than 300 kW. The program consists of a team of utility and industrial technical specialists and engineers who conduct a detailed plant audit. Audit recommendations are provided to the customer in the forms of a written report. Recommendations consist of a list of energy-saving opportunities together with project cost, savings, and utility incentive. Although simple motor and light replacement are often recommended, these reports focus on improving the customer's commercial or industrial process. As such, the recommendations can be complex or recommend significant plant operating changes. In order to assist customers in pursuing these more costly options, utilities have set up various forms of financial incentive mechanisms. Depending on the customer's financial demands, incentives can be in the form of direct cash rebates or financed through their energy bill. Some utility programs include a lease or credit option that enables customers to receive the benefits of efficient equipment while repaying the utility through a customer service charge. The Commercial and Industrial Motors Program offers incentives for the installation of efficient motors that range in capacity from 1 horsepower up to 200 horsepower. These types of motors are in broad applications in industry. Customers can realize significant energy savings attributable to long motor run hours. This program is implemented through a cash rebate to retail motor distributors based on the sale of efficient motors that are sold at the same price as standard efficient motors. The objective of the program is to pay for the added cost of efficient motors that exceed state and national motor efficiency standards. The new construction program offers design assistance for architects and engineers. Many types of energy-efficient equipment is eligible for this program. Utilities pay financial incentives for the installation of efficient equipment beyond minimum state and federal building efficiency standards. All large commercial and industrial customers are eligible to receive power quality service. The service consists of a comprehensive power quality audit to identify problem areas. This is rapidly becoming an important feature of utility services as power quality gains in importance in the commercial and industrial sector. Now let's look at advanced industrial technologies and services. Advanced gas and electric technologies can be used to increase production, lower total operating costs, and reduce environmental risks. and to improve product quality. Advanced industrial electrotechnologies are being used in various water filtration and purification processes by municipal water customers. The resale of recycled water to governments and industry for irrigation or processed water needs provides economic justification for plant investment. In order to be more responsive to customer demands, utilities are looking for new ways to meet their customers' needs. Some of these new services feature interactive telecommunications, real-time pricing, and special economic development zones. Interactive telecommunications is an outgrowth of the utility's existing and often extensive underground fiber optic cable network. In recent years, utilities have begun to install fiber optic cable together with their traditional underground electric power cable as the electric grid has expanded. To date, this network has grown to provide an extensive communication system that is capable of providing a broad range of telecommunication services to customers. Another new service offered to select customers is the ability to precisely control their energy costs based on the actual cost of electricity. This service is known as real-time pricing. That is to say that customers can elect to pay the actual cost of energy instead of the annualized energy cost of electricity that is represented in standard electric rates. Real-time pricing requires the ability to receive the pricing signal and to be able to respond to it through any of the various energy management strategies discussed earlier. Finally, utilities are establishing economic development zones. The zone features low energy rates and assistance with construction documentation in order to lower building costs and to encourage startup business development. In conclusion, a great opportunity exists for utilities and industries to work together to identify and implement mutual business solutions. These solutions will meet the business needs of both utilities and industry. This joint partnership between utilities and industry should focus on the identification and installation of cost-effective projects to improve energy utilization. Increased productivity, lower operating costs, increased profitability, and increased competition are some of the benefits that can be realized from this joint partnership. I wish you luck in your efforts. Thank you.
Thank you, Mr. Sandoval. Before we begin the second question and answer session, we would like to apologize for the brief interruption of our satellite transmission. Now, let us begin our second question and answer session. Our first question is in the form of a fax from KTV in Brazil, and it has to do with how much the decrease in the energy consumption in the United States can be due to energy conservation on the one hand, and how much might be due to transferring energy-intensive industries to developing countries.
I can't quantify my answer, but it is my belief that most of the decrease in energy consumption per unit of output, which stated another way could be an increase in the intensity of energy usage, is largely due to conservation and demand-side management and customer efficiency measures. There has been a tremendous increase in the numbers of those programs over the last 5 to 10 years. Mr. Sandoval is the expert on that. I am not, but I do know that they've had a great impact. It is also my belief, but I don't have hard evidence at hand, that it is unlikely that the decrease is due to exporting inefficient, highly energy-intensive industries that may have formerly been operating in the United States and then would move elsewhere. My sense is that it is more likely that labor-intensive industries would have been exported from the United States. It also seems to me that an inefficient energy industry in order to move, would incur a substantial amount of costs in so doing, and would be unlikely to replicate that same inefficiency in constructing a new facility at another location. And indeed, the cost of relocation and the new facility and the general translocation cost, strike me, is probably less than it would take to upgrade the facility domestically in order to achieve energy efficiency.
Thank you. Our next fax is from Pemex in Tabasco, and I would like Mr. Sandoval to respond to this question. Is there a feasibility in Mexico for the use of wind-based energy?
I have to begin by saying I'm not an expert in the wind industry in Mexico, but clearly there are opportunities in situations where you have wind availability. One of the first things to do before embarking on the construction of a wind project is to conduct measurements of the actual availability of wind in a given region or in a given zone. You want to do